Hello everyone, I am Miss Pallavi Shezwa, and in this video today we will going to discuss on indeterminate forms. In previous video we have seen that what is the indeterminate form and indeterminate form of the type 0 by 0 and infinity by infinity. In this video we see indeterminate form of type 0 into infinity, its example, indeterminate form type infinity minus infinity, its example, and indeterminate form type 0 raised to 0, infinity raised to 0, 1 raised to infinity, and its examples. First, we say indeterminate form type 0 into infinity. This kind of limit is called an indeterminate form of type 0 into infinity. We can deal with it by writing the product f into g as a quotient. That is, f into g, either we can write f upon 1 upon g or f into g, which is equal to g upon 1 upon f. This converts the given limit into an indeterminate form of type 0 by 0 or infinity by infinity, so that we can use L'Hospital's rule. See the example based on this. Limit x tends to 0, x ln of x. We can see this is the indeterminate form of 0 into infinity. Okay, so we can write x as 1 upon x. Then we have 1 upon x tends to infinity as x tends to 0. So limit x tends to 0, x into ln of x is equal to limit x tends to 0, ln of x upon 1 upon x. So we can use here the indeterminate form. Take the derivative of ln of x, which is 1 upon x, derivative of 1 upon x, which is equal to minus 1 upon x square. Okay, after simplifying this, we get limit x tends to 0 minus x, which is equal to 0. So limit x tends to 0, x ln of x is equal to 0. In solving the example, another possible option would have been to write limit x tends to 0, x ln of x equal to limit x tends to 0, x upon 1 upon ln of x. This gives an indeterminate form of the type 0 by 0. However, if we apply L'Hospital's rule, we get a more complicated expression than the one we started with. See, if we writing like this, so we get our example complicated. That's why we simply use limit x tends to 0, x ln of x is equal to ln of x upon 1 upon x. In general, when we rewrite an indeterminate product, we try to choose the option that leads to the simpler limit. See the next type, indeterminate form of type infinity minus infinity. If limit x tends to a, f of x is equal to infinity, and limit x tends to a, g of x is equal to infinity, then the limit x tends to a, f of x minus g of x is called an indeterminate form of type infinity minus infinity. For example, compute limit x tends to pi by 2 sec x minus tan x. First, notice that sec x tends to infinity and tan x tends to infinity as x tends to pi by 2. So, the limit is indeterminate. Here, we use a common denominator. Limit x tends to 0, sec x minus tan x equal to limit x tends to pi by 2. What is sec x? It is 1 upon cos x minus tan x is sin x upon cos x. So, we can write it as limit x tends to pi by 2, 1 minus sin x upon cos x, which is equal to limit x tends to pi by 2 minus cos x upon minus sin x, which is equal to 0. Note that the use of L'Hospital rule is just simplify 1 minus sin x tends to 0 and cos x tends to 0 as x tends to pi by 2. So, for 1 minus sin x, we take its derivative, which is equal to minus cos x, derivative of cos x, which is equal to minus sin x. Next, see the indeterminate form 0 raised to 0, infinity raised to 0, 1 raised to infinity. When we use several indeterminate form arise from the limit x tends to a, f of x raised to g of x. limit x tends to a, f of x is equal to 0, and limit x tends to a, g of x is equal to 0. It is of the type 0 raised to 0. Limit x tends to a, f of x is equal to infinity, and limit x tends to a, g of x is equal to 0, which is of type infinity raised to 0. Limit x tends to a, f of x is equal to 1, and limit x tends to a, g of x is equal to plus or minus infinity, which is of the type 1 raised to infinity. Each of these three cases can be treated in either of two ways. See, taking the natural limits, let y is equal to f of x raised to g of x, then ln of y is equal to g of x into ln of f of x. Writing the function as an exponential, f of x raised to g of x is equal to e raised to g of x into ln of f of x. Recall that both these methods were used in differentiating such function. In either method, we are led to the indeterminate product g of x in f of x, which is of type 0 into infinity. See the example. Calculate limit x tends to 0, 1 plus sin 4x raised to cot x. First, notice that as x tends to 0, we have 1 plus sin 4x tends to 1 and cot x tends to infinity. So, the given limit is of the form 1 raised to infinity. Let y is equal to 1 plus sin 4x raised to cot x. Use the method taking natural log on both sides. We get ln of y is equal to ln of 1 plus sin 4x raised to cot x, which is equal to cot x into ln of 1 plus sin 4x. So, L'Hospital rule gives limit x tends to 0 ln of y is equal to limit x tends to 0 ln of 1 plus sin 4x upon tan x. Cot x we can write it as 1 upon tan x. Take it is a L'Hospital rule. Take the limit. Take limit x tends to 0. Take the derivative of ln 1 plus sin 4x, which is 1 upon 1 plus sin 4x. Again, derivative of 1 plus sin 4x, which is equal to 4 cos 4x upon tan x. Its derivative is sec square 4x. Then apply the limit, we get answer 4. So, what we get? Limit x tends to 0, 1 plus sin 4x cot x is equal to limit x tends to 0, y. So far we have computed the limit of ln of y. However, what we want is limit of y. To find this, we use the fact y is equal to e raised to ln of y. So we get the answer limit x tends to 0 ln 1 plus sin 4x raised to cot x is equal to 4. We can write it as limit x tends to 0 e raised to ln of y is equal to e raised to 4. So in this video, we see the indeterminate form 0 into infinity, indeterminate form infinity minus infinity, and indeterminate form 0 raised to 0, 1 raised to infinity, 1 raised to 0. Thank you.